Hi everyone. In this video we will talk about dissociation. Dissociation is a property that is related to ionic compounds. We talk about properties of ionic compounds where we say that ionic compounds are soluble in water, and it is dissociation that makes them soluble in water. So as I talk about dissociation, it will be the review of the properties of ionic compounds as well. We've been talking about properties of ionic compounds since the past unit, that ionic compounds are formed by the transfer of electrons. We have a cation, we have an anion, loss of electrons, gain of electrons. So the transfer of electrons, it has ions, cations and anions, and each cation in the structure is surrounded by an anion, and each anion is surrounded by the cation. So they do a three-dimensional crystalline structure. So that makes them, they have very strong electrostatic forces, means that these ions are holding each other very tightly, and because of this very specific structure, they have a strong high boiling point and high melting point, because they have very strong electrostatic forces of attraction between ions. So they're hard, brittle solids. They have high melting and boiling points, and they're solid at room temperature. And all of these properties are possible because of the strong electrostatic forces between the ions of ionic compounds. They're solid at room temperature because of those electrostatic forces. Ionic solids don't conduct electricity in the solid form. They have to be dissolved in water to be good conductors. Ionic compounds are good conductors, but only when they're dissolved in water. So, as I said, we will talk about this particular property in detail. So, the chemistry of dissolving. Basically, the question here is that when I have the glass of water and I put a spoon of salt in this, what happens to the salt as it goes into the water? So we know that water is a polar molecule. It has positive and negative ends, and we know that sodium and chloride is an ionic compound. So I have positive ions and negative ions, and partial negative, partial positive is right here. Okay, so what happens is that the positive end of the water will pull out the chlorine, so it will surround chlorine, and the negative end of the water will pull out the sodium. Okay, so the sodium and chlorine will be split back into their ions. The thing that I added as a compound will be dissociated. It will break down. So when I put this into water, water will split it back into ions. If water does not split it back into ions, water will not dissolve it. Notice that I did not write NaCl plus water because I am not writing a chemical equation. It is not a chemical reaction. It is a solution. It's a physical mixture. So when I write sodium ion, I say AQ at the bottom, and this AQ means aqueous. Aqua means water. So basically what this is telling me is that sodium is dissolved in water and chlorine is dissolved in water. So it is water that did this. So if I take Na2O and I put this into water, what water will do, it will split it into sodium plus and oxygen minus 2. You know the charges already. And I have two sodiums here, so I will put that as a coefficient. Okay, so whatever I'm doing right now is dissociation. This process of splitting into ions is called dissociation, and this is called dissociation equation. So let's go back to the notes. I have aluminum carbonate. It is a solid to begin with. When I put that solid into water, water will split it into 2 aluminum ions and 3 carbonate ions. And I put AQ in the parentheses, means water did that. And no, since it has been dissociated, no, it is a good conductor of electricity. Okay, so dissociation is basically splitting of a ionic solid into its ions. So if you notice again, another example, This is a solid. So this S means solid. So I take a solid sodium sulfate, put this into water. Water will give me two ammonium ions and only one sulfate ion. These charges come from their actual charges, the ones that you have memorized. So I can take any of those compounds and write a dissociation equation. So if I have FeCl2 and I take it as a solid, it is very important that you write these symbols. So yes, I take it as a solid and it gives me iron plus 2. Now how do I know it is plus 2? Because I switch this back. So iron plus 2 and I have two chloride ions. So 2Cl minus 1. Okay, and I have to put AQ, otherwise it will be a wrong equation. Okay, so it will be solid. It will split into solid and aqueous ions of iron and chlorine. So what I'm writing right now is the ionic equation of dissociation. Um, let's see, what does it say? So now we will be talking about writing complete ionic and net ionic equations. So before I write the long equation of ionic and net ionic, I want to talk about ionic equation, more about ionic equation. So hold on. I have silver nitrate. So if I take silver nitrate, okay, and I take this as a solid, all right, it will split into silver plus 1 and nitrate minus 1. Okay, so this will be AQ. Whenever something is in ionic state, that means it is dissolved in water, so it's AQ. Again, if I take MgCl2 and I dissolved in water, it will be Mg plus 2 and 2Cl minus 1. And again, it's AQ, means it is dissolved in water. Okay, so these are the ionic equations. Let's talk about ionic and net ionic equation. So here is a chemical reaction. I have silver nitrate, and you see AQ means this silver nitrate is already dissolved in water. So you have a solution of silver nitrate, and then you have a solution of magnesium chloride. Now, based on what I have been talking about, that solution means that they are in the form of ions. That's what the solution means. That means that the silver nitrate that I see here is not sitting out as a solid. It is in the solution form. So how many ions of silver do I have here? I have 2Ag plus 1, and 2 is also good for nitrate. So I have 2NO3 minus 1 because it is dissolved in water. So you put AQ at the bottom here. And then I have Mg plus 2, and then I have 2Cl minus 1. In the product, you see that this solid means it is not split into ions. So I will not split that into ions. I'll keep it as solid. And the one that is AQ is the one that I need to split. So it will be Mg plus 2, and I have 2 nitrate ions. So this is a long ionic equation. Okay. Now what I'm going to do is I'm going to cancel out the common ions. Common ions are called spectator ions. So I see there are some common ions, which is ion on the reactant side and it is ion on the product side. So I have magnesium as an ion here and I have magnesium as an ion here. Then I have nitrate as an ion here and nitrate ion here. So what is left now is that I have 2Ag plus 1 plus 2Cl minus 1, and on the product side I have 2AgCl as a solid. So this is called net ionic equation. This is called ionic equation and this is net ionic equation. This is called, you're basically writing a dissociation equation. Again, spectator ions are the common ions. So the ions that are ion on the reactant side and ion on the product side. As you see, I had magnesium as an ion there, Magnesium is the, come on, my pen is giving me a hard time. Magnesium is the ion on the product side, and magnesium is the ion on the reactant side. So that means it is a spectator ion. Same is with the nitrate. Because silver is ion here, but silver is not the ion here. Same as chlorine is ion on the reactant side, but it is not the ion in the product side. So I'm talking about spectator ions that are common ions on both sides. Net ionic equation is when you cancel out the spectator ions. So it is it is just written better that you have nitrate, okay, and you have magnesium, and what is left, just bring down whatever is left, okay, which is 2Cl minus 1. You have to put AQ here, and you have to put AQ here. Whenever something is ion, you have to put AQ. And on the other side, you have 2 AgCl as a solid. So this is net ionic equation, whereas this long one is called ionic equation. Okay, we will discuss it more and practice it more in the class. So right now you just need to take notes. Thank you very much.